This is lesson 2-9 from the Algebra Readiness textbook. For today's lesson, you will need a sharpened pencil and your notes packet. You'll find these study guide questions in your note packet. Please pause the video and begin working on the study guide questions, followed by these review questions up through n plus 8 equals 19. When you have finished, resume the video and compare your answers to mine. The first question of the study guide asks us to graph the solution of the inequality on the number line. A is less than or equal to 5. We learned in previous lessons that we start by placing a circle at the given number 5. Then I want to indicate all numbers that are less than 5. Numbers that are less than 5 go to the left. Then I need to ask myself, should I fill in the circle at the 5? The way that you figure this out is to ask yourself if 5 meets the criteria of being less than or equal to 5. And the answer is yes, it does. So that means 5 is a solution. So we fill that in. The next question in our study guide asks us to graph the solutions to -4 is greater than or equal to t. We learned in a previous lesson that our variable always needs to come first. So we need to flip that around to start. Let's rewrite this inequality with our t first and our -4 last. The sign has to be decided, but we want to keep the meaning the same. So I look at the sign in the original problem. You learned that the alligator eats the bigger number in elementary school. And so in this case, when I look at the original problem, I see that -4 is bigger than t. So when I rewrite it, I need to be sure that my new equation, t is less than or equal to -4, means the same thing as the original. Now I'm going to graph this inequality. I start graphing this inequality by putting a circle at -4. I need to indicate numbers that are less than or equal to -4. Numbers less than -4 go to the left. Then I ask myself, should I fill in the circle? Is -4 less than or equal to -4? And it is. And by now you have noticed that anytime there's this equal to in the symbol, that circle is always filled in. The next question on our study guide is, a road has a speed limit of 50 miles per hour. Write an inequality that describes the legal speeds for motor vehicles. So we need to write down, we're going to use the variable r, and I need to decide what the symbol should be. Now I cannot drive faster than 50, I need to drive slower than 50. Numbers that are slower than 50 would be less than 50. If it's a speed limit, that means I can drive no more than but equal to 50. So I am going to say that it could be equal to 50. It's very important to get good at reading inequalities from a number line. Hopefully you looked at this. Now I used X for all of my answers, but hopefully you used whatever letter you want, so don't get hung up by the letter. And you should have always named whatever number is by the circle. That's important. So these are the numbers. Then, let's see. So for the first one, oh, it's not going to show up. Okay. So I used X. I see that the numbers are going to the left, so that's less than 7. Then I see if the circle is filled in. It's not, so I just leave it X is less than 7. For the next one, I'm going to use X and 2. Then I decide that these numbers that are shaded on the number line are bigger or going to the right, so X is greater than 2. Now, is the circle filled in? It's not, so I don't use the equal to. The next one, x is less than 3. x is less than 1. X is greater than -3. X is greater than 1. X is less than -4. X is greater than, oopsie, did anybody catch that? X is less than or equal to, because this one is filled in. Number 8, x is greater than or equal to 6. Number 9, x is greater than or equal to 4. And number 10, x is greater than or equal to -2. Just another review problem of solving this equation. Remember, when you solve an equation, we start off by drawing a line through our equal sign so that we can clearly see the left and the right side of the equation and keep those sides balanced. I start with the side that has my variable. I notice it's adding 8. The inverse of adding 8 is subtracting 8. Notice that the side by the variable always becomes n plus 0, or just n. 19 minus 8 is 11. And then, as always, we check our work, and by substituting 11 back into the original problem and copying the rest of it exactly as is. 11 plus 8 equals 19. 11 plus 8 is 19. So yes, our answer is correct. Today's learning target is to be able to solve one-step inequalities, and then we're going to graph those solutions on a number line like what we did in our previous lesson. Now, solving inequalities is exactly the same as solving equations. So this should be really fun for you in that it'll be very easy to learn it. The first thing you're going to do is draw a line, this time through the inequality instead of the equation. Then, like my last example, notice it said n plus 8 equals 19. Here I have n plus 8 is greater than or equal to 19. Watch how similar the steps are. N is adding 8, so I use the inverse and I subtract 8. And I get n is greater than or equal to 11. When you're graphing the solutions on a number line, I only need 2 numbers. So I'm actually going to remove this number line and just demonstrate how you would do it on your paper. Here is 0, here's 11. Numbers greater than 11 go to the right. It is also equal to 11, so I fill it in. See how similar it was? It's really combining 2 previously learned concepts. Now this one. Draw a line down the inequality. That's the first step. The second step is to get or isolate my variable. I notice that my variable is on the right, so I'm going to start on the right. Y is adding 14. The inverse of addition is subtraction. I keep the sign. -26 plus -14. That, I know when my signs are the same, I add the 2 numbers and I keep the sign negative. So now I've got -40 is greater than y. But you've learned in the past that we want our variable always to come first. So let's put the y first and -40 on the other side. And then looking at this sign, do you see that -40 is the bigger of the 2 numbers? So I need to make sure that when I switch the order around, that I keep my sign showing that -40 is still the bigger number. So it really, in essence, flips the inequality sign. So here is 0, -40 is to the left of 0. Now I need to show numbers that are less than -40. And I do not fill in the circle. All right, I would like you to pause the video and try these 2 problems. Then come on back and compare your answers. Hopefully in working this problem, you saw that m is adding 3. So we are going to subtract 3 from both sides. I am left with m is greater than 3. So I'm going to put a circle at 3, and I'm going to draw an arrow showing numbers bigger, and those numbers are to the right. 3 is not greater than 3, so I'm going to leave that open. Please do not do this. Also, where you go up and then over. Also, please do not put your circle above the number line, and make sure that, so you want it right on the number line, and also make sure that you are putting it right on the number that you're talking about. Letter B. Hopefully when you solved this one, you saw that to make this equal 0, you have to subtract 8. T is less than 7. So I'm going to put a circle at 7. Numbers less than 7 are to the left. And do not fill it in because it's not equal to. All right, one more. Give this one a try. All right, hopefully when you're looking at this one, you see I was subtracting 15 from my variable. The inverse of subtraction is to add. So I added 15 to both sides. 3 plus 15 is 18. N is less than 18. On your paper, have a 0, have an 18, and then put a circle at 18. It's not equal to, so I'm going to leave it an open circle. Numbers less than 18 go to the left. All right, it's time to pause the video and try these 3 problems. Okay. I believe that this one was t minus 5 is greater than or equal to 11. I don't know why that disappeared on me. I will solve these. This is m is minus 3, so I'm going to add 13, to both sides. M is greater than 52. On a number line, here's 0, here's 52. Numbers greater than 52 go to the right. Notice I didn't fill it in. Letter B. I'm going to add 4 to both sides. I put an 11 on there. Numbers less than or equal to 11 are this direction. Okay, and the last problem. This is subtracting 5, so you should add 5 to both sides. T is greater than or equal to 16. On my number line, here's 0, here's 16. Greater than or equal to, so I fill in the circle because it's got that equal to. Here we go. Nearly 768 megabytes of memory are available for running your computer. If its basic systems require 512 megabytes, how much memory is available for other programs? Always read word problems at least twice. Nearly 768 megabytes of memory are available for running your computer. If its basic systems require 512 megabytes, how much memory is available for other programs? So the memory for basic systems is 512. That information is right here. Plus the memory for other programs. And right here, it tells us to let M represent the memory from other programs. Is less than the total memory. The total memory is 768 megabytes. Then you're asked to solve in order to figure out the value for M. To solve, you draw a line down the inequality. I subtract 512 from both sides. M is less than 256 megabytes. And then you could graph that answer on a number line. Okay. An airline lets you check up to 65 pounds of luggage. One suitcase weighs 37 pounds. How much can the other suitcase weigh? So an airline lets you check up to 65 pounds of luggage. You cannot go over that amount. One suitcase weighs 37 pounds. How much can the other suitcase weigh? Let's call L luggage. So 37 pounds is the first suitcase, plus the weight of the second must be less than or equal to, up to 65 includes 65 pounds. Then we're ready to solve. I'm going to subtract 37 from both sides. And then make sure you label. The remaining suitcase can be any weight up to or exactly 28 pounds to still meet the criteria of the airline to have less than or equal to 65 pounds of luggage. Okay, the last one. -3 is less than or equal to x plus 7. We're going to subtract 7 from both sides. -10 is less than or equal to x. Then x is on the right-hand side, and remember, we always want our x on the left or first. So I'm going to write x there and -10 here. Then I look at this sign. Which number, -10 or x, is the bigger value? X is bigger, so I need to make sure that it's showing the same message of x being bigger when I change the problem around. Now I'm ready to graph it on a number line. And I'm going to graph it right here so that you can again see what it would look like on your paper. Here's 0, here's -10. Greater than or equal to -10 has a spot here and an arrow going to the left, or going to the right. All right, give this a try.